Who jumps out of perfectly good airplanes in the name of science? Mr. C.
Well, happy Aloha Friday, 7th graders. Hey, good news right off the bat. I do not want to forget. So I am moving next week's test back to Thursday. So I just need the time. I want to review a lot. I want you to really be ready. I want you to remember a lot of that information. So test next Thursday. So anyway, this weekend, if you're bored and you find you're picking your nose a lot, and just don't have anything to do, you might triple R your study guides. Mr. C, that is not happening. That's fine. I just threw that out there as an option. So anyhow, thought you might be interested just a little bit. Hey, I wanted to show you the hat today again. It's an Aussie-Australian hat, and I'm pretty sure my grandson's got a rugby match. Today's, let's see, it would be on Saturday, so it'd be tomorrow out in Australia. So anyway, have you noticed how the wind keeps coming up, going down, cools off, warms up? Typical March and now into April, same kind of weather pattern. Jet stream's way north, jet stream drops down, kind of close, but it hasn't been low enough to bring any moisture. Jet stream goes up, jet stream comes back down some, brushes Arizona, causes wind, no precipitation. So I'm still praying, holding out for some actual precipitation and maybe even more snow in the high country. So anyhow, I'll check next week to see if we've got any more runoff into our lakes and raising our lake levels. So anyway, good news, end of the period. I've got a little video for you on hair, human hair, or the lack thereof. Like how much you have growing out of your head. So, and just the complexity of hair. In fact, I think that's the title of it, The Complexity of Hair. So I'll introduce it in a little bit. If you sevens will take out, please, your lesson summaries. If on that white sheet that you've got, if you will number to, why not number to 12? Number to 12. Okay. So number to 12 on that. And my goal today is to go over the last lesson summary, LS4, it's on the back, on drifting continents, and I'd like you to highlight things on it. So anyway, just a little practice on your white sheet. Might count, might not. Do your best. Don't look at anybody else's papers. All right, here we go. All right, first, the questions I asked today, I guarantee are going to be on the test. Guarantee. Number one, the scientific study of the earth. We're going to go fast. Number one, scientific study of the earth. You few RLO students out there, I really do want you to do this. Now, no one's exactly monitoring you. Please be honest. Please actually do this. So number one, the scientific study of the earth. These are off of LS1, which you're not looking at right now. That would not be right. Okay, so anyhow, all right, evidence that we get about the Earth's interior. We get magma coming up, and then it comes out as lava, so we get an idea what it's like on the inside. Indirect evidence. We've drilled down about, what is it, 7 something miles down That's a long way down. We've drilled down that far and brought up samples, core samples of what it's like. So on the test, they'll ask you that. One of the ways we know what the interior of the Earth is like. 2, 3, and 4, and 5. Starting on the outside going in, what are the 4 layers of the Earth? Write them quickly, please. 2, 3, 4, 5. From the outside, in further, in further, in further. So write them down quick. Four layers of the Earth from the outside in. Okay, let's keep it going. Please be honest. Number 6. What do we call, I have a nice sample of it, what do we call the name of the volcanic rock, igneous rock, that makes up the ocean crust? The bottom of the ocean, lots of this. So what is it? And number 7. Got to write it down. Number 7, what is the name of the rock that makes up the majority of the continental crust? And here it is. I call it the salt and pepper one. Lots of it, chunks of it on campus, all over the place. Big chunks of it. So that is number 7. So what is it? You gotta write it down. Okay, 8. So number 8. Give a very short answer. Why is the very inside core of the Earth, even though it's so hot, 10,000 degrees Fahrenheit, we think, it's solid, it's not melted? Why? Okay, questions off of LS2. Let's do 9 and 10, and I'll give you the last one. So give me 2 answers in number 9, half each, 2 answers in number 10, and I'll give you S for solid. The 4 characteristics of minerals. So in number 9, give me N and I, and in number 10, the 2 C's. What do they stand for? The 2 C's in number 10, unique this and unique that, start with the letter C. Number 11, what do we call the characteristic of any mineral? Any individual characteristic, one-word answer. What's it called? A. So number 12, and some of those characteristics, there's a bunch of them. Minerals have these characteristics. They've got a certain hardness. You know, diamond's the hardest on the Mohs hardness scale. Diamond's a 10. Talc you can scratch with your fingernail. It's a hardness of 1. You've got luster, how it reflects light. You've got streak. I don't think I've shown you a, here, let me show you a streak. Here's what it is. So I have it. This mineral, here it is. So one of the tests you can do is use a streak plate. It's really hard. It's like ceramic tile, so it's super hard. And you scratch the mineral on it, and most minerals will powder on it and make a color, a streak color. So this is hematite, and it makes kind of a reddish orange color, which we're not surprised about. So that's streak color. So all of those are characteristics of a mineral. And number 12, what do we call the atomic packing characteristic? How tight the atoms are packed. Like in diamond, they're super tightly packed. In talc, really loosely packed. That's why you can scratch the particles apart. So what do you call that? I'm just going to do one more. Lucky 13. I don't believe in unlucky numbers. 13 is as lucky as any number. No such thing as luck. So in 13, give me one way that crystals are formed. One way crystals or minerals are formed. There's a couple of ways that we went over. It's all from LS2. So give me one way, and then I'll give you the answers really quick. Use another color or pen or pencil as you grade it. Mr. Phillip is paying attention, monitoring. Just want to see how you did. I'm going to collect these, so you'll put your name, date, period, upper right-hand corner. Okay, here are your answers. So, by the way, how you did will tell me how well you paid attention, how well you've triple R'd. You're supposed to have been triple R'ing these lesson summaries. So, it'll tell me a lot of things. It's data, and I can make some conclusions about you. So, that's why we're doing these. Okay, how well you're paying attention right now. All right, number 1, geology is the answer, study of the earth. Number 2, crust. Number 3, mantle. Number 4, outer core. Number 5, inner core. Crust, mantle, outer core, inner core. Number 6, this is basalt. Basalt, and I should have taught it to you this way, basalt found at the bottom of the ocean, in the oceanic crust. Basalt at the bottom of the ocean. It'll be on the test, guaranteed. And then, where is it? Here it is. And then granite, this is number 7, makes up the majority of the continental crust under our feet. So granite. And then number 8, why is it solid in the inner core? Because of the extreme pressure of all the layers pushing down. Pressure is the thing I'm looking for. Lots of pressure, extreme pressure. Okay, that's why. And then 9 and 10, I ask you to give me a 9, N and I, naturally occurring, natural, not man-made, and inorganic, the I one, not from living things. So naturally occurring, inorganic. The 2 C's, unique chemicals, unique crystals. Chemicals, crystals, half each. Number 11, the characteristic of a mineral is a property. Number 11, property. Number 12, the property that involves atomic packing, density. 13, one of the 2 ways that minerals are formed, either cooling of magma, either in the earth or squirts out of the earth and cools as lava. And that's it. So 12 was density, 13 cooling or dissolving. Cooling or dissolving, either one. All right, number right over 13, be honest. Number right over 13, name, date, period, upper right-hand corner. You may not hand it in. Are you listening? You may not hand it in until you put name, date, and your period in the upper right-hand corner. First and last name. Print it neatly so I can actually read it, please. First and last name printed, the date, and today is 4/9. And your period, just P and P1, P2, P3, P4, P5, P6. All right, if you'll pass it in. Thank you. Okay, now if you'll turn to LS4, I want to show you this, then we'll do some of the additional minerals. So LS4, I want you to highlight in the bottom of LS4, you can see Continental Drift down there in the bottom of the top box. See that? Continental Drift. And here's the idea. There's a guy by the name of Wegener. I'm not going to ask you his name, but he suggested way over 100 years ago. Let's see if it says exactly when. Actually, yeah, 110 years ago, 111 years ago, Alfred Wegener suggested that the Earth was at one time one landmass, and then he says slowly, but the Great Global Flood would have done it quickly, that the continents moved to their current positions. So here's his idea, Continental Drift. You've highlighted it on LS4. And that idea of Pangea that you see there, he says there was one landmass at one time, which that's the way God probably made in fact, almost certainly made the earth. And then the Great Global Flood rapidly broke the earth up into its plates and caused the plates to move to their current position. So anyway, Continental Drift. So you've highlighted it. Mr. C, is that all you want us to know on LS4? No, I want you to also know what are some evidences that at one time there was one landmass. Here are the evidences. First, the fit of the continents. So I'm going to ask you these. Write these on LS4. Why do we think there was one landmass at one time? The fit. See how the continents fit together. So kind of the puzzle nature of the continents, and if you kind of brought them back together, they would fit. Not perfectly, but close. And animals would be able to move around. And speaking which, we find the same kind of fossils at the edges of the continents that at one time fitted. So it'd be like this, same fossils here, same fossils here. So that's evidence that they were at one time together, same fossils, right there. Also same kinds of rocks. So same fossils, same rocks, the fit, and then the mountain ranges. Similar. Mountain range here on that edge, same kind of mountain range made of the same kind of rock at the other edge. That may have fit at one time. Continental drift. Evidences again, get them down on LS4. The fit or the puzzle nature of the one landmass at one time. The fit. Continents would have fitted together. Identical fossils on the edge of each that fit. Rocks and mountains, mountain ranges. So those are the biggies. So I wanted you to see those. Okay. So now let's see how many additional minerals we can get through. So you've got this sheet out. And I think we've done, what have we done so far? How many? I think we've done 10. Was 10 our last one? I'm looking. We did slate, shale to slate. We did that. Did we do 10? I'm looking. Yeah, iron pyrite. Iron pyrite. And here it is. This was 10. Iron pyrite is fool's gold, right? It's very dense, loaded with the iron. People found it and thought they had gold, but they didn't. So that'd make you sad. All right, number 11, let's see what we've got for number 11. Number 11 is quartz. It's the white-colored quartz, number 11. So if you'll find quartz on your first page. And It's an abundant mineral, so you can highlight that. Most sand is made of small pieces of quartz. So sandstone, little grains of quartz. Quartz crystals, beautiful. Look at that crystal. All quartz crystals have this shape. Unique crystals, yeah, same shape. Quartz. Quartz, very abundant in the crust and most sand. And probably stop right there with that. So that is quartz. All right, and this is number 12. Number 12, and I think Mr. Phillip might have samples of these as well. Number 12, it's limestone, so find it and write 12 above limestone. And down below it just says there's many kinds of different limestone. And probably, I'll be honest, probably what I'm going to ask you in the test on this, this particular mineral forms marble when it's heated and squeezed, when it's metamorphosed. So number 12 forms marble. So I think, there it is. We've already done number 8, marble. Shining stone, real sparkly. Do you have it in front of you? Maybe. Let's see. I know I had a nice sample of it. So, yeah, I don't currently have one in this box. So number 12, limestone. And then 13. So number 13 is this one. Do I have it? Yeah. This one is bauxite. Bauxite. And it looks like it's got like little kind of like round divots or holes in it. Bauxite. So find bauxite. It's on the back page, I think. Bauxite. It's on the back page. And it contains aluminum metal. It contains this metal. We get most of our aluminum that we use a lot because it's strong and very light. It's not the strongest, but it's strong, depending on how thick you make it. Not in this Coke can, but anyway, aluminum metal found in bauxite. You know how you might remember it? You might remember AB. Aluminum, A, is found in bauxite, AB. Lots of aluminum with an A found in bauxite with a B, AB. Aluminum in bauxite. Say that to yourself, not out loud. Say it to yourself, it'll help you remember it. Lots of aluminum in bauxite, AB. So, number 13, we are making great progress. And then 14. You're going to have to trust me on this one. I'll try to remember to show you this next week. Number 14 is pumice. It's igneous, volcanic, and it's extremely light. Extremely light. In fact, it's so light and low density, it's less than the density of water. Water is 1.0 grams per cubic centimeter, and pumice, you'll have to believe me on this. I don't want to tip it too much. I don't want to get water on the ground, so I don't think there's any way to show you. There, you can see it a little bit. You see it's floating. This rock is floating. It's floating in the water. It is so low density. Pumice. Pumice. Lots of little holes. It's volcanic. And is it on the back page? Mr. C, where is it? There it is. Sorry. Front page. So highlight a couple of things on it, have a look at it. This volcanic rock was called Pumice by the Romans. It comes from their word for foam, spuma, foam, so it's kind of like foam. And it's used for polishing things. We use it for that, actually, for polishing or smoothing out things. So, because it's really rough. So, anyway, pumice, very low density. All right, let's go for 15. We are on a roll. 15. Okay. Here it is. Do I have it? Let's see if I have it, actually. I'll go on to 16. You're going to have to remind me, Mr. Phillips is going to have to remind me that I need to come back to it. So, all right, let's do 16. It's on the second page. Here it is. I have a big sample of it, a big chunk of it. Big chunk of sandstone. 16 is sandstone. This is loaded with quartz grains, tiny quartz grains. I don't think you can see any of the crystals up close sparkling. Can you see any of the sparkling going on there? You can actually see just sparkles everywhere. And when you handle it, you get, you'll have to trust me on this, you get little bits of sand on your hands when you handle sandstone. Not a surprise. Let's read about it, and it'll be the one we wind up on today. Sandstone is a sedimentary rock. You knew that. You might, in fact, put to the side of it GGF. GGF, so you're writing on your paper, GGF, formed by the Great Global Flood, mostly composed of quartz grains cemented together, used as a building stone or decorative stone. So sandstone. Okay, I told you I was going to show you a video on human hair. Let's just see, why are you doing that, embarrassing yourself? Actually, it doesn't embarrass me to not have that much hair growing out. God gave me my DNA. I don't think about it really ever. It's just me. It's the way God designed me. I'm good with it. Anyway, so, and I still have some hair growing out. So I'm going to show you the complexity of hair. So find your journal for this one and write down a few bullet facts on the complexity of hair. And then Mr. Phillip will take over and handle, say, any questions you have that you want an answer to. So take it away, Mr. Phillip. The complexity of hair video coming up.